Bismillahirrahmanirrahim. This video is from chapter 13, Ideal Transformer, and here we'll be solving question number 46 and chapter question from Mr. Hayt's book. So this is the question. For the circuit given, we have to calculate Ix, that means this current Ix, and V2 is the secondary voltage. The first thing, if you note, this is an iron core transformer. These bars actually show the iron core transformer, and an iron core transformer is taken as an ideal transformer, and the transformation ratio is 1:5. That is, secondary is 5 times more than 1. Now we'll draw some of the missing currents, etc., from this circuit. First of all, this current I1, and this will be, at this point you can see the current is dividing into I1 and Ix. That means the current through this branch is I1 plus Ix. Similarly, this current is I2, and two currents are adding at this point to go to 140. So the current through 140 is I2 plus Ix. Also, this voltage is given marked, but this one is not marked. We'll mark it, we'll call it V1, and positive at the top, negative at the bottom. Now, before we start, we have to understand these two lines. If V1 and V2 are both positive or both negative at the dotted terminal. So see the circuit. Our V1 is positive at the non-dotted terminal, and V2 is positive at the dotted terminal. Look here, V1 and V2 are both positive or both negative at the dotted terminal, then use plus N. So we have to use minus N because we have an opposite scenario. One is at the dotted terminal and the other is at the non-dotted terminal. So what does this mean is that we can write V2 over V1 is equal to minus N2 over N1. Now N2 over N1 is actually small n, this small n. And this is equal to minus 5, this 5 over 1. From here we calculate V1, or we can write V1 as negative 0.2 V2. This is the first two lines. Similarly, if I1 and I2 both enter into or leave the dotted terminal, use negative sign. Now in our case, the current is entering the non-dotted terminal. This current is also entering the non-dotted terminal. So both entering or leaving the dotted terminal, then you have to use minus N. So we have to use minus N in case of a current, because the current is actually, you can also see that it is leaving the dotted terminal. This one is also leaving the dotted terminal. So both leaving the dotted terminal. So I1 over I2 will be negative N2 over N1 and equal to negative 5 over 1. So I1 is equal to negative 5I2. Now these two relations we'll use to simplify the circuit. Now the first thing we'll do is write the KVL equation for mesh number 1, mesh number 2, and the outer mesh. You can also try to solve this by nodal analysis, but I think mesh analysis is much easier here. Okay, so KVL in the left mesh, we start from here, negative sign, so negative 188 angle 30, 4 times I1 plus Ix and plus V1. So this is the left mesh. Similarly, right mesh is negative V2, 3I2 and 140 I2 plus Ix. And the third one, the outer one, starting from here, negative 188, then is 4 I1 I2, then is 10 Ix, I1 Ix, then 10 Ix, and then 140 I2 Ix. So this is what we have written. Since we want to find the answers of Ix and V2, we should replace or get rid of I1 and V1. So we'll use the equivalent that we found to replace I1 and V1. We found this relation, we'll use this now. First equation was this. We'll first of all open and regroup them. And then from here, we now put the value of I1 from here. And also we replace V1 with V2, minus 0 to V2. Rearrange. And so this is our final equation, 1a. Similarly, here we don't have I1 or V1, so no need of replacing, but we'll just arrange them, rearrange. So this is the final shape. And the third equation was this. Here we have I1, so we'll again open all these terms, rearrange, and then we replace I1. So replacing I1 and solving again, we get the last equation, 3a. So we have these three equations now, and we need to find I2 and Ix. So we have to eliminate V2 here from here. Now if you look these two equations, you can eliminate V2 if this is also becomes 0.2. So multiplying this whole by 0.2, multiplying by 0.2, equation 2a, we get this terms, and this we calling equation 2b. And now if we subtract these two, this one we subtract from the second one. So subtracting, we bring it down, and in subtraction, you know, the sign changes. So this negative will become positive, positive will become negative, negative positive, positive negative, and then we add these, so it will be 48.6, this one will be 24, and this one will be negative 188. Okay, now this equation is purely in terms of I2 and Ix. We have another equation which is also purely in terms of I2 and Ix, that is 3a. So we write them together, and now we again eliminate one of the terms. So we'll try to eliminate Ix first. So we can multiply this. If we multiply this by 154 over 24, then we'll get 154. So 154 over 24 is actually 6.41667. So multiplying with that, the lower term, we get this new equation, equation number 8. And now we'll subtracting this, we get this new term. From here we'll find I2, this equation. And now that we know I2, we can find Ix. We from here you can find Ix. Putting in the value of I2, we get Ix to be 10.75 angle minus 30. So now we have these two currents. We need to calculate the voltage. We have already written the KVL equation, so we'll just start with that. Simplifying, arranging, get this term, further arranging, we get this term. Now we put in the value of I2 and Ix. So putting the value of I2 and Ix and solving, the value is 192.26 angle minus 30 volt. So I hope you have been able to follow this. Please let me know if there is any mistake. It can be corrected, but this is the procedure that you have to follow. Thank you.